Now in analytical geometry in grade 11, some new work that we do is inclination angles. Your inclination angle is basically the angle that is formed between the x-axis and your straight line. So it's this angle. And we get this formula. Your gradient m is equal to tan theta. So if we look at an example, if AB is extended to cut the x-axis, calculate its inclination angle. So they want us to extend this line to the x-axis, and then they're talking about this angle as the inclination angle. So we can immediately start to write down that we know that tan theta is equal to the gradient of the straight line. So for m, the gradient of AB, we can write it's YB minus YA over XB minus XA. So here in the top, we start with the Y values, which is 2 minus 1 over the X values, 4 minus 3, which becomes 4 plus 3. So this then is equal to 2 minus 1 is 1 and 4 plus 3 is 7. So because we've now determined the gradient of the straight line is 1 over 7, we can write tan theta is equal to 1 over 7. And this is now simple. If you look at your cost, I have to remind you of trigonometry now. This angle lies basically in the first quadrant. And because of this, we don't need to work with a reference angle. We are just going to work with the normal angle. So in your calculator, you can type shift tan 1 over 7 and you get theta as equal to 8,13 degrees. The next example works a bit differently. They now ask us to calculate the inclination angle of BC. Now BC, as you can see, has a negative gradient. So if we write our cast again of trigonometry, you can see that this angle is in the second quadrant, which means it is no longer an acute angle in the first quadrant. We're now working with an obtuse angle in the second quadrant. For this reason, we're going to do this a little bit different than the previous example. We can again begin by writing that we know that tan theta, this is our theta angle, is equal to the gradient m. So I need to determine m for the line BC. That's equal to YC minus YB over XC minus XB. So for our Y values, we have minus 3 minus 2 over 9 minus 4. This gives us minus 5 over 5, which is minus 1. And this makes sense because we know that we have a negative gradient here for this line. So now, whenever you get a negative value here for your gradient, you need to remember that we need to now work with what we call a reference angle. So in your calculator, well, we can first write tan theta is equal to minus 1. But instead of writing or typing shift tan minus 1, in your calculator you will type shift tan positive 1. And you get your reference angle of 45 degrees. So this is your acute angle that we are working with as the reference angle. Now, if I can remind you again in trigonometry, in our first quadrant, we worked with theta. In our second quadrant, we normally worked with 180 degrees minus theta. Third quadrant was 180 degrees plus theta, and fourth quadrant, 360 minus theta. Because we're now working in the second quadrant, we are going to deduct our reference angle from 180 degrees. So we will write that theta is not equal to 45, but it's equal to 180 degrees minus 45 degrees. And that gives us the answer of 135 degrees for theta.